We're on? Great, okay. It took us a while before we got there. All right, so today's lab. Today's lab, we're gonna do a bunch of double replacement reactions. Okay, we're gonna do some double replacement reactions, and we're gonna make precipitates. So first and foremost, the double replacement reaction has the formula AB plus CD makes something. The double replacement reaction, the partners switch places. Now we're talking about ionic compounds, so A in the front is positive, B in the back is negative, right? That means C is also what? Positive and D is negative. So in a double replacement reaction, what is going to be one of the products we're going to make? A, D, and CB. A is positive, it was positive here, it's going to be positive there. D is negative, C is positive, D is negative. Okay? That's a double replacement reaction. Make sense so far? Now, everything that you're going to be using today is aqueous. All of these are aqueous. But we're going to put them together and we're going to make precipitates. What's a precipitate?
Falls out of the solution.
Simply falls out of solution. Other New Year's resolution. I'm going to throw candy at people for no reason. So yeah, a precipitate is a compound that forms, is no longer soluble, so it falls out of solution. What it practically looks like is a powder that forms, making the compound or the solution cloudy. Okay? So one of them is going to be a precipitate. Let's just say this one's going to be our precipitate. We write an S after it, and this one's going to stay aqueous. Make sense so far? So this is what you're doing. Give me a thumbs up if you're with me so far. Okay. Wave your hand around if you have a question about this double replacement stuff or precipitates. All right, so what you're going to do is you're going to get one of these spot plates. I love these things. Spot plates are like a plastic dish with 24 tiny beakers. So 6 by 4, 24 tiny beakers. And I asked period 2 and period 3 to make sure they cleaned them really well, but some of them did, some of them not so much. The good news is they're brand new, so if you want a brand new one, you can get one of these. I just ask you that when you're done, you clean them out really well. So you can get yourself a spot plate. And then you're going to get a compound, cobalt chloride. And into the cobalt chloride, you're going to add some drops. Drop, 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 drop. From the cobalt chloride into the spot plate. Then you're going to choose something else. Sodium hydroxide. Drop, 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 drop. And you're going to look at it. Did a precipitate form? So to figure out if a precipitate formed, get a piece of scratch paper, put it on your desk, and go black, white, and see if it turned cloudy.
Wait, do what?
So you're going to put your spot plate is going to be on your desk like this, which is black. Get a piece of paper and go black, white, black. Yeah, it did change something. It used to be this color, now it's this color. It used to be clear, now it's cloudy. Make sense? So if it changed, it became cloudy, a precipitate has formed. Some of them are going to be really significant. You're like, whoa, it turned brown. And some will just be, it was pink, now it's pinkish cloudy. Make sense? All right, so if a precipitate forms in that combination, you're going to write yes. So you're going to do these combinations. All of these are going to be done. So your first combination might be sodium phosphate with silver nitrate. If you go sodium phosphate, drip, 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 silver nitrate, drip, 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 and then it forms a precipitate, you would write yes.
Yay.
Or Y. Yeah.
Does it matter which one you put in the
It doesn't, yeah, because they're just okay. And you can do them in any order. You're going to do the whole combination. The reason that half the table is X'd out is because that would just repeat it. You don't need to. So you're like, I got calcium chloride, and I'm going to react it with sodium sulfate. Did it make a precipitate? Yes or no? Make sense? Okay. Unfortunately, this isn't really third period's fault because second period got them all mixed up and I kind of gave them to them in a messy way. They're all over the place, but they're all up here. So what I recommend you doing, not right now, but in a second, is grab like 2 or 3 just so you can do a certain number of combinations. Then when you're done, bring them back. Okay. with my instructions so far, does this make sense so far? Give me a thumbs up if you're with me. Okay, wave your hand around if you have questions. Okay, so you're going to have this filled out with yeses and nos. Not all of the combinations will make precipitates. For solubility rules that you can learn if you want to take AP, some compounds just will stay, they'll stay aqueous. Some will form precipitates. If you flip your lab over, you're going to see two more charts. In this top chart, you're going to identify what the AD and the CB are. Okay? So you're going to look at the combinations. For instance, in this first box, sodium phosphate has sodium ions and phosphate ions, and silver nitrate has silver ions and nitrate ions. The combinations that AD and CB would be are silver phosphate and sodium nitrate. Does that make sense? So in this second box, we're going to be spending quite a lot of time, you're going to determine what are the products. They're all going to swap partners. What are the products going to be? So, for instance, in this next one, silver nitrate and calcium chloride, you're going to make silver chloride and calcium nitrate. Make sense? Now, what is the rule in making compounds? They have to zero out. The overall oxidation must be 0. Which means, if you have a phosphate which is -3, and a sodium which is +1, how many sodiums do you need? 3. You're going to need 3 +1s to balance out that 1 - 3. Okay, good? Okay, that's part 2. And then the graded part. Part 3. In part 3, what you're going to do is you're going to look at which reactions made precipitates, where your yeses are. And you're going to say, all right, this box here was a yes. Based on what I've seen in my entire reaction, it is probably that compound. It's going to be one of the two. So in part 3, you're going to look at part 3 and say, based on some trends I've seen, of those two compounds, my precipitate is most likely that one. So I have compound A, compound B. If it's like let's say I notice that this ion frequently makes precipitates. Almost every time that ion was involved, I got a yes. Then if I see it, I'm like, oh, it's that one. It's probably that. That's probably the precipitate I'm going to write down. Make sense? Or if you look at it and say, you know what, I noticed when I used this ion, it almost never made a precipitate. So of those two, I'm not going to choose that one, I'm going to choose the other one. Cool? The number of precipitates, I'm going to say more than 5, less than 15. So somewhere in that ballpark. Hopefully you haven't contaminated your chemicals. Okay, does that make sense? Now, that's all we're going to get to today. In fact, some of you might not be able to finish part 3. Perfectly fine. We're going to work on this tomorrow too. Okay? But definitely get all of your data and start part 2, or at least get part 2 done, maybe start part 3. Okay. One last thing before I release you. I'll ask you for questions in a second. You'll notice that a lot of these vials look a lot alike. A lot of these dropper bottles look a lot alike. Please, for the love of my sanity, do not take all the caps off a bunch of bottles and set them aside. Because then what will happen is you'll put the wrong cap on the wrong bottle, and it'll form a precipitate in the stock bottle. Because some chemical will leak in there, and I'll be like, throw it out, make it over again. Okay? So if you, let's say you take this copper, take the cap off, set it aside. Set it right next to it. Magnesium sulfate, take the cap off, set it right next to it. Okay? Make sure the caps don't get mixed up. Can you handle that? Yeah. All right. Questions? Yes.
So that means the ones that are colors that are up there.
I'm not sure what you mean.
Like, so the ones that, so like, have different colors.
You can absolutely use them.
Oh.
So, like, it's like, okay, so copper sulfate, it's blue, but you can see right through it. When you make a precipitate, it's going to go like cloudy blue, or it might turn green or brown or red or purple or something. I can tell this one already needs to be thrown away because it has like little pieces in there already. Oh well, such as public education. Okay, other questions? All right, last thing. I wrote it on the lab, but it is kind of handy. The proper way to use a dropper is vertically. If you don't do it vertically, you can get it on your hands, you can get it all over the place, so vertically, drop, 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 drop. That being said, if you're ready to go, give me some thumbs up. If you have questions, wave your hand around. Okay, now this is a really hard part. You ready? Tyson, can you press the silver button again?
I found this on